This is a video about tuning the Telewave TWPC-1505 with the DSA 815. First thing I do is I establish the reference here, but before I do that I usually hit System and Calibrate now. And it'll take a few seconds and it goes through its little process. Alright, then I go to tracking generator, set it to 0 dBm, turn it on, and it should give me a line across here that will be 0 dBm roughly, minus whatever these cable losses are. I put a bullet in between the two so that it's going from the tracking generator straight into the spectrum analyzer. So this is really the loss of the cable. Looks like it's about 0.49 at 154, well actually 155 megahertz, and at 146.52 megahertz it's about 0.58, so pretty much within a tenth of each other across that whole range. So I have that on trace number 2 here, which is writing this continually right now. Hit that again and freeze that. So there's a reference level. The purple line is the reference level. I've turned on the trace 1 here. Number 1 is yellow. And you see that we're about 2.6 dB down from there, so about 2 dB down. So that's about as tight as you want to have the tuning on this. With 2 dB of loss, you're going to have some matching problems potentially. But anyway, that's it's on 154.96666 at the moment, and we want it on 145.52. So I'll take my tuning tool and put it on the unit here and bring it down in frequency. And tweak that a little bit by hand here. So now we're pretty much centered up on 146.52 instead. Now that's fine, but it's not real good tuning because there's 600 points across here, and so this is not necessarily that accurate at this point. But what we can do is to change the span here from 20 megahertz to 2 megahertz. And now we have a lot more refined tuning than we did before. So if I tweak it a little bit more with my hand here, all right, I just moved it right onto the frequency. We got about 2.8 dB, it looks like, of loss. So we're still in the same neighborhood as we were before, a little bit more, but it's definitely peaked at the right frequency. Remember, you've got to take whatever this is, which is 2.8, and subtract what this is, which is actually 0.5, so it's not 2.8, it's actually about 2.3. You'll note that the tracking generator goes into the port here, and the spectrum analyzer comes out and goes through the spectrum analyzer port here. And the device under test will be going here, but right now it's open, so I get a full reflection, which means 0 dB return loss. And indeed, that is what we see on the spectrum analyzer up here. But you also notice that it's about 15 dB down, 15.6 as a matter of fact. Well, that's because there's loss in this bridge, so we have to compensate for that, which is done by hitting amplitude on the regal, and reference offset. Half of this is part of this, of course, So I'm going to make it, rather than 15.6, I'm going to make it 15.1 dB of reference offset. So we'll press that button and go 15.1 dB, which, as you notice, has dropped down here, but this is also changed. So we'll go back up there and make that 0 dBm. You notice that this line is now right across where the purple line was. And that's because we now have the thing calibrated to the same level. So now we're going to take the coax from the TWPC-1505 and put it on here. And now if we look at the spectrum analyzer up here, we'll see that we have a pretty darn good match. At 146.52, in fact, our match is 16 dB. Well, that's not quite as good as we'd like to see. We'd like to see more than 17, and we'd like to see it centered up, actually. So now I'm going to tweak on the cavity here by loosening these screws. And rotating this back and forth until I get the match that I want. I'll show you how that looks on the analyzer. Okay, but we're still around 15 on the 146.52 frequency, so we'll have to adjust the screw a little bit to get that down. There we go. So now that's down below 20, and that's good enough. We can get it right on if you'd like. Let's try that. There we go. We're at 27 dB and centered up on the frequency band there. So it's probably shifted this peak up here a little bit, but not enough to be worried about. It's not going to make more than a 1/10 of dB difference on that side of things. So there we are, we're tuned up, and we may be able to jockey between the tuning of the port for this and the tuning of the center conductor for that, and get a better balance than we have. You see that it's a little bit off, skewed towards the low end here on the match, rather than the high end here. So you can balance that out by playing with it, but I don't think it's necessary in this particular instance. I placed this summary on the end of the video. You can stop it at this point and review. Step 1 is to self-calibrate and also set up the tracking generator to find the place where things are tuned at the moment. Step 2 is to use the tuning tools to tune the thing to wherever you want to place it. Step 3 is to calibrate the return loss bridge or a directional coupler for the return loss measurements. Step 4 is to perform those measurements using good quality cable and a precision load on the cavity. And then to recheck everything and peak and jockey back and forth until you get the results that you really want to get.